Hey everyone, this is your class that is Enolate formation of unsymmetrical ketones. Okay, so thermodynamics versus kinetic control enolate formation, and it is a very important topics for your exam point of view. That is, ketones are unique because they can have enolizable protons on both sides of the carbonyl groups. And this is the cyclic ketone, you know that, but two side in here in the this one and this two, the two hydrogens are symmetrical. Okay, so if base is used, the formation of enolate anion is same. Okay, on one side of the ketone having no enolizable protons, then also only one enolate can form. Okay, so if there is no enolizable hydrogen, then only this side is for formation of enolate. Okay, but selective enolate formation can also be done if an unsymmetrical ketone have enolizable protons on both sides of the carbonyl group. Okay, so this is the formation. If there is CH3 group and one hydrogen group, and here two CH2 group is also, so there are formation of two paths for enolate formation, path 1 and path 2. Okay, so these hydrogens are also active, and this hydrogen is also active. Okay, so basically two enolate is formed, but which one is more stable? So the more stable anion is formed here. The formation of two different enolates, whether A1 is measured or 2A is measured, depends on two factors. Okay, first is temperature and next is nature of base. Temperature dependence, that is kinetic control product. Okay, so enolate with more highly substituted C double bond C bond in the thermodynamically more stable in the same way to as for alkene, and it will be formed predominantly under condition that permits the establishment of the equilibrium. Such enolates are thermodynamically stable. Okay, so basically the mechanism is this: less acidic alpha hydrogen, because there is CH3 group and the CH3 group have plus I effect which push the electrons towards this, so this is less acidic, but these hydrogens are more acidic. Okay, so the base, if the base is present path 1, more stable anion is this, and less substituted alkene, less stable enolate ions. Okay, so less substituted alkenes, but here less stable anion. Okay, but most substituted alkene is present here, so this is thermodynamic enolate. Okay, so effect of temperature: removal of a hydrogen from less substituted alpha carbon to produce an enolate is usually first. Okay, due to a steric reason which gives more stable carbon ion intermediate, and therefore this will require lesser active energy, and this will called kinetically controlled product. Okay, and the diagram is here, that is energy diagram. So more stable anion intermediate, this green color, and less stable anion formation, that is the black color. Okay, so the product is D and E, formed via less activation energy, that is kinetic enolate. Okay, and formed via